Good afternoon, my fabulous chemistry students. Video number 4, solubility factors. When we are done with today's notes, we will be able to predict if a solute will dissolve in a solvent based on our new solubility factors that we learned. So we need to understand this term like dissolves like. Well, what does that really mean? What it does mean is that nonpolar solvents will dissolve nonpolar molecules and polar solvents will dissolve polar molecules. Oh, polar. There's one of those things we learned from bonding, polar molecules. It's going to come back up into play now. So, solubility factors. Factor number 1 is what we call nature of the solute and solvent. In other words, polar, nonpolar. So a nonpolar solvent into nonpolar solvent into a nonpolar solute will be soluble. A nonpolar solute into a polar solvent will be insoluble. See how that works? Like dissolves like. A polar solute into a nonpolar solvent will be insoluble. A polar solute, or a polar solid, goes into a polar solvent, soluble. Ionic solute, salt. If I put it in a nonpolar solvent, it is insoluble. Salt in alcohol. But if I take that salt and I put it into water, soluble, polar solvent. Okay. While we're there, I'll tell you that water is known as the universal solvent. Okay. So, styrofoam demonstration. I'm not going to do that demonstration for you right now in the video. What I would like you to do is predict which one you think is going to happen as far as water and styrofoam and acetone and styrofoam. Which one's going to dissolve and which one's going to be insoluble. You predict, and then I will show you in class when we get around to this piece. Okay. Factor 2, temperature. Okay. For solids, as we learned on table G, as the temperature goes up, the solubility will go up. Okay. So the gases have a negative slope and the solids have a positive slope from table G, remember? So for most gases, as temperature goes up, the solubility actually decreases. If I heat soda, I will make it go flat faster. Okay. How do we remember this? Well, remember, temperature is average kinetic energy, the measure of average kinetic energy. Kinetic energy is the energy of motion. The higher I get the gas, the more it moves around. The more it moves around, the more those gas molecules get to the surface and can escape into the atmosphere. Okay, how's that? Pressure. For liquids and solids, basically there is no effect. I'm going to say there's none. There might be a little, but for our case and purposes, there's no effect. Okay? But gases is a different thing. So as the volume decreases, solubility increases. Okay, and I don't like that it says volume decreases. How about as the pressure increases? Okay, as pressure increases, well, we know that if the pressure increases, the volume of the gas decreases. But let's think about it on top of the liquid. If I put pressure on a gas on top of a liquid, won't that force the gas to go down into the solution, into the liquid better? Right. And our good example is our soda pop, right? We keep the can, it's under pressure. When I open that, you hear it. When you first open the can of soda, you hear that pressure get released, right? The longer I leave it like that, the faster it's going to become flat, as we would like to normally say, or decarbonate. The gas is going to leave eventually. So what we like to do is with our 2 liters, put the top back on. Well, they actually sell these funny tops for 2 liters. They have like a push pump, like they were in the toes of our sneakers. We could pump up our sneakers back in the day, remember? Well, they make one of those for 2 liters. You screw it on the top, you pump it a few times, it puts pressure on the soda, and the soda will then stay carbonated longer. If you take a 2-liter bottle of soda and you squeeze it thin because you've drank half of it and you put the top on, that's going to create a vacuum and it's going to try and open up. As the 2-liter tries to open up, the vacuum's going to be greater. It's going to pull the carbonation right out of the liquid to take space of that vacuum, and you can actually flatten your soda faster by squeezing the 2-liter. And I don't know anybody that really wants to do that. All right, so very important. Please listen. Do not stop this tape as you think you're finished with your notes, because you're not. Now you can predict the solubility of substances based on just the situation. Okay, temperature, pressure, like dissolves like, nature of solvent, solute. But more importantly, practice packet page 8 and 9 you can do now. Quiz number 2 prep has to do with this solubility. And then there is a quiz number 2, solubility factors, on Castle Learning that you will be good at if you take the prep first. Notes are done under 6 minutes. Hoorah! Be well.